Hello, everybody, and welcome to the second part of week 3 for game development. Today we'll be talking about Sneaky Sneaky. So, Sneaky Sneaky will be building off of everything we've been building up to. We've got a manager now, we're able to interact with individual agents that are all using state machines and things. So, we're going to put this all together in kind of a game type form. And there are instructions as well as a feature sheet. We'll probably hold off on talking about the feature sheet until Monday. We'll see how today goes. But the basic instructions, you can start working straight from your previous assignment. I would recommend copying that assignment to a new location just so that you have that one to fall back on and you have the working project all good to go in case you do screw something up and need to just revert. There is this tutorial here talking about how to get point and click navigation actually working for a player. We'll be walking through that today in lecture as well. And then a bunch of resources for how this, what you might need for this task. So here's the instructions kind of describing how it should work out. As far as what you'll be making, I believe there is a link right here. You're kind of going for kind of this Zelda type puzzle after we skip past this little climbing part, but where you've got to try and create a puzzle where your character has to sneak past these guards as they're going to their different nav points and pausing and things like that. So your goal as a game designer is to come up with a few different setups, 4 in total. There should be 4 different areas, kind of like this, of a puzzle for our player to get through. And that's the basic gist of it. Here's a completed project that we can take a look at. So we've got 4 different areas clearly set up. No actual puzzle pieces like any locked doors or anything like that, or pushing buttons or pulling levers. It's just all about avoiding the guard and navigating through. Or avoiding the guards, I should say, because there can be more than one in a room. So here's the first room in our gameplay window. If we take a look, we can press play. And we have our player over here starting off in kind of a safe area. We can click and it'll actually navigate around using those navigation things that we've learned. It's the same way that our guards are navigating around. They should look very similar. They're doing basically the same thing as our previous assignment was, where they're just going to the different points. If I press right arrow, oh, and didn't mean to click in the center there, we can select a certain guard. And we can issue it different commands. Let's pretend our player has some sort of stun functionality, and when you target a guard, you can stun that character or put it in the pause state. So when we press the 1 key, it pauses. We can unpause it. If we press the 2 key, it'll reverse the direction that it's actually going through these nav points as. That one's going to be hard to see, but this one, it's going this, and then this one right now, so in kind of a clockwise pattern. If we tell it to reverse, oh, and I should have selected that one if I want that one to reverse. We've now got it going into a clockwise pattern, actually going back to the last one after it hits the first one, then to the middle, then back to the first, then back to the end. So it's changing how it's working in the array rather than incrementing, it's doing a decrement and going to the previous nav point instead of just always going forward through the array. Only working during the idle state. So that would be considered partial credit. It should change immediately as soon as you press the button. So you may want to look at how you're telling it to change that bool, and then also take a look at how you're telling it to go to its next point, because there are 2 different places or 2 different functions that are used for that. And That'll actually bring up a good point, but we'll talk about that a bit later when we're covering some of the other features and actually implementing them into this. We will not cover all of the features that you have to do. I want you to try some of these out on your own, and then on Monday we may have a little bit of a recap to try and give you that little bit of extra push that you might be struggling with. But for today, we will talk about how to get a player character set up, how to get a camera set up, and stuff like that. As far as the guard states, we may look into the distract state a little bit, but we'll talk about that right here. There is another state, so right now it's reversed, but if I press this button 3, it's what I consider a distracted state. I believe the document calls it an alarm state. There should be something in the level that you can treat as kind of like an alarm. And when you press that, it pulls it off of its normal patrol path, has to walk over to the alarm, and when it touches that alarm, it'll just go back to idle or return back to its normal state. So let's say I wanted to get both of these guards distracted real quick. Oh, and of course I distracted him into me. Well, that is the one last part that you'll have to do. The pursuit state, which is something we haven't fully covered yet. We did talk about like a follow state in the previous lectures if you wanted to review that. As far as how it should switch to that state, you can have it based off of time. If it's tracking you for too long, it can go back to normal, but it should be based off some sort of collision detection if the player's close, within a certain range, or even if you're doing like a ray trace to see if it has line of sight of the player and stuff. That is totally up to you how you want to implement that. This one right here, this example has it just based off of a collision volume that's around our player. So when it gets close, it tells them to start pursuing. When they leave the volume, they just go back to normal. And then the camera transitions. The camera is totally up to you as well. This one has some static transitions, like they're just static cameras placed in the room to show the entire room. When you hit a trigger on the way out of the room, it switches to the next camera. And very last thing, I think the very last thing, yep, showed just about everything, is going to be the end goal. I do want to talk about like the lose scenario. If the guards touch you, I would not have any lose scenario to make testing a little bit easier. Since this is a programming type assignment, I'm mainly here just looking at the functionality of the guards that are switching states. Can you select all the guards? Can you actually use the state machine that we've provided and add additional functionality? So the end goal, though, or the winning scenario, is when you touch a trigger volume towards the end of the game, it should let you know that you've escaped the game. Now, I do accept if you just print out in the console you escaped, but doing that little bit of extra effort and getting it on a screen UI is something that you should be able to knock out in a couple minutes, really, at this stage. So I would like to really try and see that displayed in-game. So that's the general idea of how the game should function. And over here we have the same agent manager that we left off with last time. If I press play, we can cycle through the guards. They have the little indicator, mine's placed above their top of their heads, and we can issue them a command to pause. So for this, let's go ahead and take a look at what happened, how we can add a player character to this and kind of lay out our levels. We'll talk about some organizational techniques to try and keep everything properly organized and stuff. So first up, let's go ahead and add a new player character here. I'm going to do a 3D, I'll use capsule since I prefer capsules. drop that into the field. We'll say it's 2. We'll scale it up since all our other objects are pretty big. Make it 2. And we'll just put it right at 0, 0, 0. And we're going to need a script to control this. So we'll put the script in our scripts folder. Create a C# script. Just call it player. And rename our capsule and attach our script before I forget. Player. And we do want this using the navigation system. So I'll go ahead and add a nav mesh agent component to it. Attach our script. All right. Player's pretty much good to go. Got to get it actually moving when we click, though. Don't care. And here we are. First thing we'll need to do is get a reference to our nav mesh agent component so that we can set a destination. So nav mesh agent is a type of component. I'm just going to call mine nav. Looks like IntelliSense didn't quite find it right off the bat. But we can always see potential fixes. Adding the using statement that contains that AI stuff. Yep, let's just use that. Then we're good. Then in the start, we need to grab the navigation component from our game object. So our nav equals get component of type nav mesh agent. And then an update. We want to check if the player presses the left mouse button, if input.getKey. And I often have this question of why do I use a get key down instead of get mouse button down for this. And the reason for that is because I want this to be generic type code that I can reuse later. And if I wanted to ever remap that from a mouse button, using just a key code of these mouse buttons allows me to swap out this one little element rather than having to rewrite the entire if statement, just changing which key I'm using. So if we press that mouse button, we want to do some sort of raycast. You guys should be familiar with raycasts already. They're going to return a bool on whether they hit or not. Let's do, this is in the physics system, physics.raycast. There are 16 different functions here that we can use. It's overloaded 16 times. That means they have different types of parameters that can be passed in to be more specific or give you more information. These first two just take array and return a bool. That doesn't give me a lot of information. I want to know exactly where this hit was. So this third one, though, takes an array of what our mouse is clicking on and stuff, and then returns out a parameter of hit info. So an out parameter is actually just like another return. So we're not only getting did it hit something or not, we're also getting an entire structure about what it hit out of this. So we'll use that one. We need array for this. So we will be asking our input for where our mouse is and then converting that to world space using our camera. So we want a ray, call it mouse ray. We'll set this equal to our input mouse position. That's just a vector in coordinates on where we're clicking in the screen, but our camera from our main camera has something called screen point to ray. There's even screen to world point. We'll go screen point to ray. And we'll just pass in that mouse position, which if we do hover over this in pixel coordinates, so that is screen space. So we'll convert that to a ray that we can then pass in mouse ray. Our second parameter, in order to use this third overload, needs to be an out and raycast hit info. So I will say out raycast hit, and we can give this a call. We'll call it just hit. Use that suggested name. And what this one line is doing, it's going to create this structure, pass it into this function, and the function will actually fill it out with all that information. So we then can ask our hit things like, where was the point that it actually hit? That's the thing we're looking for. We want to tell our character to move to that point. So using this, we'll tell our nav to set its destination to that hit point. And semicolon. Save this. Hop back to our game. And if we press play, should see our character get pulled onto the map because the nav mesh doesn't go all the way to the edge, and we should be able to click around and get it moving. Now our character's moving pretty slow. I don't necessarily like that. I like it being a little bit faster than the guards for purposes of testing. So I'll click on our player. We'll go to its nav mesh agent. We'll say it can move 10, and it can perform a full 360 within 1 second. And acceleration, we'll bump that up, say 14. All right, let's just play again. And we see our character is much more snappy and quick with its actual movements. Has to wait for all those other guards to get around, but it itself is moving pretty quickly. All right. So next up, let's take a look at setting up another area just to the right of this or to the top of this, or I've even seen some people do like vertical levels, like they were going up a floor on like a business building or something and had to navigate through that. The layout itself is completely up to you how you want to do the layout, as long as there's 4 distinct areas for the player to try and navigate through. So we're going to select everything in this area 1. In fact, we'll add a new, we'll create an empty child, zero it all out. And we'll call this area 1. And we'll put our agents in there, our nav points in there. Agent manager I'll leave out because I just want one manager to manage all the agents in the level. Path blockers are level specific. Cameras not level specific. The terrain is though. So we'll copy that terrain. Move that into area 1. Now, if we want another area, we can then just, I'm going to reorganize this a little bit so that all my agents are down at the bottom, path blockers are right up top next to terrain, and points are in the center. All right, Let's just copy this entire area. We'll go ahead and duplicate that. Area 1, 1, no, area 2. And we now have this entire area on top of our original area. Now I know my terrain size right here, I believe is 50. So if I just push this entire area 2 over 50 units, we've now got it perfectly lined up so that they are overlapping, or well, not overlapping, but just touching. And let's just go ahead and try and play this. Let's see what happens. Well, the guard that was here snapped over into the other area, and these guards aren't navigating at all. Anybody know what I did wrong? Well, let's take a look at our nav mesh. The arrays actually are all populated. They're populated correctly too, so that the agents here are going to trying to navigate to these sections. But the part that I didn't do when I copied, I just changed how our level was laid out. If we're changing any level geometry, our navigation has to be rebuilt. It doesn't know that it can navigate in that area yet until we tell it to bake in this area. And interesting. Agent radius is 1, height is 2, y is, whatever. We'll just bake that. Not sure if I was playing around with that just a minute ago or not, but we rebake it, yep. So baking that nav mesh now has that area all set up. Press play, and they'll all be navigating to their points properly now. But we have one more problem. Our player, if we're trying to go over into that second area, we can get right to the edge, but our camera is not going to allow us to do that. So there's a few different types of cameras that I would recommend for this setup. One of the easiest ways is just attach our camera to our player. So if we attach our camera to our player, and I'm going to just zero out these offsets for X and Z. It's looking top down straight at our player. If we press play, it'll now follow along with our player's transform. But that's not too good, especially if with the world rotating around like that. It's going to be pretty bad for motion sickness, as well as kind of annoying since you have to click on the point you're trying to go to, but your character's spinning around. So there's another way we can do this, and we can create a simple script to just remove rotation from the camera. So let's take a look at how we can do that. We'll be creating a new script. We'll just call it no rotate. Pretty straightforward what that script should do. And for this, our rotation is stored from our transform. If we look at how we can get that, transform dot not position. Thank you, autofill, but not today. We'll be checking the rotation. Rotation, the actual type it's storing, is what is referred to as a quaternion. What that is a 4-dimensional vector that fixes some 3-dimensional math problems if you're working with just Euler angles. Now, it's always represented in the editor for readability purposes of how it just direct angles. These are considered Euler angles, spelled E-U-L-E-R, pronounced Euler. And that's very easy for us humans to relate to. The 4-dimensional quaternions don't make a whole lot of sense. You just need to know that's what form it stores it in. I could spend probably 2 months talking about quaternion math, but that's not what this class is about. So we know it needs a quaternion. Let's go ahead and create a quaternion. Quaternion. And we'll call it starting rotation. And we'll initialize it to an identity quaternion, which just means quaternion with no rotation. Then in the start function, we'll just ask our camera what its current rotation is and store that into our variable here for starting rotation. So starting rotation equals our current transforms rotation. Then in update, we'll do the opposite. We'll make sure that our current transform rotation is always going to be set to the starting rotation. So very simple script here. Just grab the rotation on start, and then in update, make sure it's always setting it back to its starting rotation. Then in the level, we want to make sure to attach our no rotate script to our camera. Press play, and now we have it following our character, but only based on position, not rotation. Now there is a little bit of an oddity that can happen if you do have the camera, let's say, offset from the player, rather than being straight down on top of it. If we had it like that and we press play, we're going to have some odd things because that offset is trying to rotate around and keep it the same orientation. So highly recommend you make the position directly above your character if you're going this route. Another route we could take is just like the one we saw in this example where there's some sort of trigger volume right here. And if I look for that, there's a triggers manager, this is their first trigger volume. So it's just a box and level that they've set up. And when our player hits it, it moves the camera to a new location. Let's go ahead and take a look at how we could set that up here. So let's just put a little trigger volume there. We'll put it inside area 1 because it's the end of area 1 transition. We'll create a new 3D object. I'll do a full cube and drop this onto the map. We'll make this bigger. $. There we go. Nice big wall, kind of dividing the levels. And we'll just go over a little bit. I'll even make it a bit fatter. All right. So the reason why I'm doing just a normal cube is so that I can see it in the level and edit it a little bit better than just trying to edit the collider. I can always just turn off the mesh renderer if I want. And I mentioned I wanted this in area 1. This will be our camera trigger. Let's create a script for it. We'll create one that the player, or that detects when the player hits it and then moves the camera to a new specific offset. So we'll create a script. We'll call it camera transition. And I did this last month too. I named the object camera trigger and this one camera transition. Let's fix that before we continue. We'll make it the same name just to keep everything a little bit simple. Camera trigger.